Okay, let's start. Hi everyone. Welcome to this session about automation and communicating machines in a way that boosts productivity and performance in manufacturing at Coloplast, Hungary. My name is Dénes Demeter. I'm a lean coach at LEI Hungary, and I will be the moderator of this session. Let me introduce also the presenters. Eszter Herpai-Oszóczky, who is an operations development project leader, and Viktor Majoros, value stream manager. They are both from Coloplast Tatabánya. In case you have questions, please, during the session, please type them into the chat box or into the Q&A box, and we will go to answer them after the presentation in the Q&A section. So enjoy the presentation. I give over the word. Eszter, Viktor, the stage is yours.
Thank you.
Thank you, Dénes. Hello, everyone. Welcome, everyone. I'm Viktor, and we are from Coloplast, Hungary. Our topic, as Dénes mentioned, the automation. And let's see the agenda. The first is the introduction into Coloplast. Next, we will see the automation part. And the third is the machine information and standard work. And the fourth is the specific examples. So let's start. Let's jump in. Introduction into Coloplast. Some words about us. Today, we are a truly global hacker company. It's a classic Danish company, which was established in 1957. And currently, we are market leaders. We have a lot of employees over the world, and we have a really wide-ranging portfolio. For instance, the ostomy care, the continence care, the voice and respiration care, the urology, and the wound care. We have many facilities on the world, but now we are focusing to Hungary because we are standing here. And in this hard period of business life, it's really not easy to imagine the growth. But in the center of the picture, you can see we have 8% organic growth. And I'm really happy about that. We try to optimize our production by the automation process. And for us, it means growth again. So some words about what we're doing here. At this slide, and during the whole presentation, we will talk about our Hungarian factory, which is located in Tatabánya. And just to know, we have two factories in Tatabánya. Tatabánya is the name of the city. And we are in the second factory. And this is the place where the automation is continuously running. So on the center of the picture, you can see this is the stoma bag. Stoma bag, our main portfolio, what we are producing here in Tatabánya. And what is the stoma? Maybe it's a question which has come to your mind. It's when a part of the colon has been removed due to the colon cancer or injury or a lot of other things that happen. So that is no longer possible for feces to exit in a normal way. That's what you have to use if something happened and you need it. So it's an extremely sensitive thing, what we have to provide for the end users to make their life easier. So this is the classic, the most important thing what we produce here. Let's see the numbers, the facts. It's really detailed information that you will see, and this is the automation parts beginning. So numbers, and I want to also highlight again, we are talking about the automated factory in Tatabánya now. So we have 10 different technology, what we had to use, what we use for production, and 61 machines, and more than 1,000 items, what we had to produce. And to imagine, this is a classic bag machine. what you use for production. And just to compare, just please compare the bag machine and take a look to the people and the size. It's really different. So this is a sample how you can imagine these machines lengths. These machines used to 32 meters long with certified sections, and we have a massive production flow in Tatabánya, and yearly we are able to produce more than 500 million products. I think it's a really impressive number.
Yes, as Victor said, there are many intervention points on each machines, and that results in the required number of the operators as well. In terms of the previously mentioned organic growth, we had to decrease our addiction of the human resources. So we decided to start an automation program in Mio production. During our automation program, our goal was to decrease the number and the frequency of the human intervention in the production area, so the machine could produce with less operators. This will result that we can rearrange our resources according to our growth. In automation program, there were some main activities which were the basic of our plans. We implement industrial vision systems to replace the 100% visual inspection on the finished goods, and that project was the prerequisition of the robotized packaging equipment implementation as well. We analyzed the previously mentioned intervention points, and we managed to identify the most frequented points from them. And that means that we have to do automation activities on that intervention points. For example, we installed automated loading systems. There were other activities as well, according to the size of the machines, the length, and the size of the production area. For example, we would like to decrease the forklift traffic in the production and give a solution to a more effective information flow to our colleagues as well. To be more specific, for example, in case of a bag machine, there are basically 3 operators working on one machine. The goal was to reach an automated level on each machine to be able to operate with only one operator. To gain that goal, we implement the vision system. We install automated packaging systems and automated loading system as well. On the next slide, you can see a short video how this looks like in real life. So let's see.
This is the plastic loading system in our machines, and release the operator. Load the machine with cheap raw material, but the system is able to feed it. The plastic packaging units with the vision system, of course, able to check the product. So the finished goods moving to the warehouse. We have a really nice palletizing machine. We can put to the dedicated places near the pallet at the end of the process. And what you see, this is a classic layout. Just to understand this image, on the left side, you can see different cluster value streams. In this case, I mean, the cluster value sims means we are working like a family. And for instance, on the right side of the layout, the plate, and the center, the filter, and the left, the multi-area, they are producing intermediates. And these materials, or let's say raw materials, arrive to the bag areas, and we are producing finished goods. And when we are talking about finished goods, it means that stoma bag. And I'm happy to say that that was the past. So currently, it's we have a total different layout. I mean, in an overview, and the reason is the automation.
As you can see in this layout, the previously presented automated equipments were implemented or will be implemented on many machines, almost every machine in this location. The light blue lines represent the paths of the intralogistic system, which transfers the finished goods from the packaging machines into the warehouse, and there the boxes are palletized by a manipulator. To ensure the effective connection between these systems and the machines, we created a production IT network and paid attention to the homogeneity of the control technology of these machines as well. During our ideas were realized, it became more and more obvious that these activities in their own won't be enough. So we need to identify that plus we need. First, we had to determine where we are in this process. In case of an automation program, there are some distinct degrees. And when we implement the packaging, loading systems or the vision systems, we create the basic conditions from hardware and software side. To create that production IT network, we create the connection between these machines and gave an opportunity to the information to flow and to share. And we have some tools to monitor our processes and the production, so we can see what happens in the production. I can say that we reached the first 3 levels at the beginning of the automation. And after that, we started to work on the transparency and the predictability. But for reach that degrees, we have to use other tools. One of these tools or a new method to reach the mentioned degree is to analyze what happened after the implementations. After we implement all of the equipment to a machine, our expectation was that only one operator can handle the machine. But in reality, it ran into difficulties, and the experiences of the operators said other. And we try to resolve that issue. For that, we start a process development activity with colleagues from LAI Hungary, for example, Dinesh, and came to that conclusion that we need to change our thinking and started to handle the machines in groups, not by one. This means that there won't be one operator, one machine lineup, but instead of that, it will be a 2 operator, 2 machine group. It sounds like it's the same, but we realize that it's definitely not. And it's really important in the future for the operators to work in a closely cooperation with each other. Yeah. For example, when they have some breaks, they can help for each other. So one operator will stay in that cell. There was another method to use reach these levels I mentioned. It's called MES, Manufacturing Execution System. This system has different modules, for example, task scheduling, visual factory, quality and logistic module, remote training platform for support the standard work, and we can integrate many other applications to that platform. So we can solve that all of the information reach the adequate persons in real time, and we only have to use one interface to get these informations. In our next point, Victor will show you how it works through some examples.
Thank you, Esther. First is the task schedule model, but before I start, I want to divide it to two sections. So the first, what Esther mentioned previously, to implement these kind of automated equipments is not enough. But of course, when we are talking about automation, this is the first step, the first phase, what we have to do. And what the second part of the automation, of course, is the software upgrading development. And this is what we call MES, Manufacturing Execution System, what we have to use to support our processes. And because during the production, there are a lot of loss. We have to walk a lot, and there are a lot of process waste. And we have to find a solution. How can we mitigate these kind of issues, risks? And at the beginning of the automation, we had to sit down, involve the operators, involve everything who will participate in the future. And we had to be a little bit think forward to how can we find a solution where we can support them and support somehow their daily work. And that was the first, maybe the first, what we have figured out, that the task schedule model, we have to implement it, of course, immediately. We usually say that word, but it's a quite heavy and hard word. So the task schedule model can generate automatically tasks for the operators, for the technicians, for the shift leaders. And we have a configuration module where we can separate, and we are able to add different orders to the different tasks. And we have various trigger methods. For instance, if I want to alert, for instance, an operator, shift leader, technician, we have performance-based triggers, item, step, time, and alarm-based. And it's really important when we are talking about mass production, because we have to produce a lot of products. And the other parts, which is really important, the reports, because the management part, it's really important when we are talking about any kind of production flow. And because of the automation, I think it's more important than ever. So we are able to get out reports from the system. And it's also interesting, and I want to highlight it, available for PDAs, PCs, or mobile phones. Okay, so it's another interesting part, the real-time information flow. So we have to find immediately the right people or thing in time. That's the key, I think, in this process. And that's why we use that ColumnMS system, what I talked about previously. So to increase the proactivity compared to reactivity. And I want to show you a short video about how it's working in real life. So we see on the screen something happened on the machine. We have to fix it. Now you got the alarm that's fixed. Something happened with the waste remover. And the PDA said, just go there and fix it. And now, okay, we fix it. We send to the done button. In the other case, when we need, for instance, a technician, need help, that's the daily case. And on the PDA with the visual screen, you see, we have to go there because somebody needs our help. That's our daily routine now, and we are really proud of that. Another point of view, what we have to see in this situation, for instance, previously we had a flow. When we are talking about welding units, it means we have a welding unit at the top of the machine, and under it we have a backplate. And for the backplate we use silicon layers, and frequently we have to change it because it's a mandatory. We have to change it because of the quality. And previously, what you see on the left side, that was the past. The machine stopped, and the machine said, you have to change this silicon layer, and it means breakdown. So the machine stopped, and the operator has to call a technician and said, please change the silicon backplate. And as you can see at the bottom of the picture, there were a lot of movements with these blue lines, which was a simple loss of the process. And that was the past, and it was 15 to 20 minutes breakdown. And with Danish and the external team, we found a proper solution. How can we fix it? And now we have the mass system, and it can say in provincial frequently, the step is coming. You have to change it in 2 hours. Please prepare for the changing, and it's going like a totally automatic way. And from 15 and 20 minutes, reduce that time to 5 minutes. And it's not a big movement, but with the automation, with the proper production, it's really important time. It's a visual factory and shift report part. It's a management tool. That's what we see on the screens, and it's really important for the management, of course, and it's really important for the operators and the technicians and the shift leaders as well. So when you want to check the information, how our production is running, you are able to check our machine numbers, the produced quantity, the quality, and the machine speed. It's really important. And just imagine, I want to show you a video about that, how it's working in real life. I'm sitting at home, for instance, of course, after the shift, the workday, on my sofa, and really want to know how it's working and what the situation in the production. I can check on my mobile phone. This is the current status by the machines. This is the visual screen, what I showed you previously on the slide. And if I want to get more information, I just move to the events feed, and I'm collecting the information by the technicians. This is the PC data. I'm able to collect more information, more detailed version by the machines, the machine numbers, the produced quantity, and the spread and everything. These are the ability collecting the information part. And what is common? I think it's built on each other. Information reaches the adequate person in real time. Real-time info means fast reaction, and proactivity means more productivity. I think this is the key message what we want to send to everybody who will start the automation. Questions and answers section.
Thank you very much, Victor and Esther. You have now the opportunity to ask your questions. Also, I can switch on personally, someone, if you raise your hands. On the other hand side, I would have a question here. What was the original size of the company in terms of operators, and where did you go with this automation?
Back in time, and at the beginning of the automation, we were more than 500 employees, operators and technicians. That was the past. And our goal, our plan to reduce this kind of number, let's say, with more 20 to 200 employees. And it doesn't mean that we have to say somebody, we're not able to provide you a workplace or a proper workplace that you can work. It's a reorganization. So as I mentioned at the first slide, we have a lot of factory, and in Tatabánya we are in continuously growth, and we can reorganize our operators and technicians. For instance, in the other factory, we can provide them almost a simple workplace where they can work.
Thank you. There is another question here. With the increase in automation, there is a growing demand for PLC programmers, technicians, engineers. And so how did you address that?
It's a challenging thing because we need more specialists about PLC, robot, vision, usually, and we try to share our knowledge internally, I think, and we try to involve new people as well,
Yeah.
and try to organize more trainings and improve ourselves with the new techniques, and to use a structured way to work inside Coloplast. But it's challenging, yeah.
Yeah, it is.
Okay, thank you. Another question: how can you? There is a new process also in regards of that, right? So the people have to work in a different way. So how can you ensure that this is working?
Yeah. So how can we say it will be fine at the end of the automation? I think the most critical point is the involving everything and to get a future view how it will look like in the future. But I think the most important message to involve and involve and involve.
Thanks.
Yes. For example, in MES system, we have different platforms where we can get information for the improvements as well. And of course, Victor has the information from directly from the operators as well.
Okay, so if there are no other questions, I would like to thank you very much for this great presentation, and I would like to wish you also good luck for the future. And yeah, thank you very much for
your attention, and hopefully you have enjoyed our presentation.
Thank you
Thanks
very
for
much.
joining us.
Yeah, I would like to thank also to the audience, and yeah, wish you a great day. Bye-bye.
You too. Bye.
Goodbye.